Hello, everyone, and welcome to today's webinar on SolidCAM's feature recognition and machining. This is Sydney speaking, and I will be hosting today's webinar and giving as well. And before we get started, there's a couple of notes I'd like to mention. One is that this is being recorded and will be available on our website. If we take a look, I believe you can see my screen now. If we take a look at our website, we have a section here called webinars. Inside that section, we have webinar recordings. So this webinar will be available later on at this point for further reference. Okay, so let's get started. Now, what exactly is feature recognition and machining in SolidCAM? Well, feature recognition in SolidCAM is not just a tool that does automation for the user, for the programmer. It's a tool that allows you to recognize the features on the part and allows you to use your technology the way you want to use it on the part. In other words, you are the machinist, you know how you want to work. The feature recognition helps you find the features and then allows you to apply your technology to those features. And this is exactly what I'm going to show you how it works inside SolidCAM. So basically, you can just say very simply is that SolidCAM is the choice for your machinist, because we give you the features and we let you decide, the user, the machinist, how you want to exactly work. So let's start by our first feature I'd like to show you is pocket recognition. What I'm going to do in this part is I want to recognize the pockets that are over here. Now, what exactly is pocket recognition before I get started? Now, instead of machining each individual pocket in separate operations, pocket recognition automatically parses the CAD model looking for all the pocket features that are identified as pockets. And then you can apply your technology to machine it. So let's see exactly how this works. What I'd like to do in this part is I'd like to machine all of these pockets that we have on this side. What I don't want to do is I don't want to go inside this hole over here. We'll see that as a pocket as well. So I want to ignore that hole while I'm doing the pocket recognition. Okay, that's what I'd like to do. So if I were to go into pocket recognition, we'll choose the home position that we want to work on. In this particular case, I want to work in my first home position. And then I go to building a new geometry, identifying our features. Now, like I said, this diameter, I'd like it not to take. In other words, anything that's that size or smaller, I'd like it not to choose it for the feature recognition of the pockets. So if before I continue, we have here what they call circular pockets diameter filters. So right now, as a default, it says 10 millimeters. If I were to activate this field like I've just done and just click on that circle over there, you'll see that it'll give me my minimum diameter. So anything smaller than that will not be chosen for the pocket. Now all I have to do is click on the part, and the pocket recognition is now parsing the part and recognizing every single pocket feature that's on the part itself. And you can see this in our list over here, as well as on the parts. You can also see that the circles were not chosen. I'll just accept this. And all I need now is just to select the tool that I'd like to use. Anyone, obviously, as a user, can decide whatever tool they would like to use. And when it comes to depth, the levels, we don't have to do anything over here because the depth is automatically picked up from the pocket features themselves. All I have to do is to determine what kind of technology I'd like to use. For example, me personally, when I work in with open pockets, and I'll go to my open pockets area, I like to use profile strategy for the pocket itself. Everyone can use what they want. This is why, like I said before, this is made so that the machinist can decide how he wants to use his technology. I'm just going to hit save and calculate. And what you'll see now is that a tool pass was being put on every single pocket that we have on the part, including this area over here and even these areas over here. Let's take a look at the simulation for a moment, and we'll use Solid Verify. And what we'll see, let me slow this down. You'll see that it starts working on every single pocket as it goes down the part. And you can see even these small edges that we see over here will also recognize, as well as these areas on top over here. Okay, now I've showed you how pocket recognition works when you're using it in this fashion, but let me show you something else. I'm going to delete what I've just done over here. What I'm going to do now is I'm going to show how pocket recognition can be made even more powerful. If you have saved your pocket recognition, if you have a template of pocket recognition, all I need to do is go to my list of templates, which I see here in my task pane on my right side, and I have one here for pocket recognition. All I have to do is take it and just drag it onto the part itself. Without even going into the operation, it'll automatically create the operation with the toolpath on it, recognizing every single pocket. Now, the templates is technology that the machinist, make by yourself. In other words, this is what you decide how your technology wants to work. Okay, I'll be getting back to pocket recognition in a moment, but I'd like to skip over now to chamfer recognition. Now, what exactly is chamfer recognition? Chamfer recognition is automatic recognition and machining that applies chamfers to the edges of the model where it is possible. It provides a very powerful capability to automatically chamfer the edges of a model without having to manually pick all the chains and apply chamfers to them, such as using a profile operation instead. In other words, we're recognizing every single edge feature on the part. How is this done? Simple. Go into chamfer recognition. Again, create my geometry. My home position is correct. And again, the filters, I'd like to apply a filter for that hole over there. I don't need it over there. So I'll activate that field and just click on that hole over here. We get the value, and now just click on the part. And as you see, it's now recognizing every single edge that's on the part. Every single edge feature we have on this part is being recognized. I'll just accept that. And when I work with the chamfer recognition, I always like to work, by the way, with 3D model protection. This will guarantee that if my tool, my chamfer mill, comes close to the edge, it will not gouge any of these corners over here. Okay, now all I need to do is choose my tool. My chamfer tool will be whichever one I have over here. Right now I have a 3mm chamfer tool. And in my levels, all I'm going to do is tell you what's the size of the chamfer I want. 0.1 millimeter. I'm just going to have an edge breaker. Okay? And in my technology, I'm also going to define what's the cutting diameter of the tool that I'd like to use. In other words, this diameter, as you see over here, as I'm pointing to now. Okay? And I'm going to say I want to use a 2mm diameter of the tool. Save and calculate. And as you can see, the tool passes were automatically put on the part. again, running my simulation in Solid Verify, you can see that went pretty fast. I'll slow down just a bit. You can see all the edges are being picked up, and you can also see that it stayed away from the very corner over here as not to gouge this corner. Okay, now just like I did in pocket recognition, I'm going to delete this operation that I created over here. And with chamfer recognition, this is probably one of the most useful ways to use it is by using the drag and drop template. Because this is something that's used almost all the time. And you almost use always, many people use the same tool many times for the chamfer, for creating a chamfer. So I'm going to take the template that I have over here, just drag it to the part, just like I did before, and look how quickly you create your operation. Just drag it, and with drill recognition, together with the drag and drop template, you have an extremely powerful tool. Now, I'm going to do one more thing before I continue with my next recognition option. I'm going to delete now both the pocket and the chamfer operation. Now, what I can also do, besides the regular templates, I can use what we call a process template. Now, this process template, in this particular case, I created one that already has pocket recognition and the chamfer recognition inside of it. In fact, I have 2 pocket recognition operations here, plus one for the rough and one for finish, plus my chamfer. All I have to do now is just drag it to the part, and in just a few moments, you'll see we'll be having 3 operations created just with one simple drag and drop. So we have our feature recognition with the process templates creating already in just a few moments, just a few seconds, 3 operations right then and there. Again, showing my simulation. You can see the first operation will go pretty quickly now because we saw this before. The second operation doing the walls, and the third operation working on the chamfers over there on the edges. Okay, let's go on now to our next part. In our next part, we're going to show something called drill recognition. Now, what exactly is drill recognition? Drill recognition is an automatic recognition of holes for drilling from solid models, with the option also to modify the results. Now, there are 2 ways to use this one. First of all, the drill recognition is a single tool operation. So I can use it with a single drill that has a specific diameter, and then recognize all the holes that have that particular diameter on whatever levels it is. Another way to use this is also if I want to do a spot drill. I can take one spot drill and put a spot on every single hole that's on the part. So what I'm going to do here is actually do 2 separate operations. One is with the spot drill, and the second one using one of the drills, one of the hole diameters that I have over here. So let's go into drill recognition. Okay. Now, when I create my geometry to recognize, in other words, recognize my holes, before I continue on the part, I'd like to put a spot drill on every single one of these holes. This one over here, I do not want to put one over there. Okay, because that's really a large hole. I'm not going to be actually drilling that. Okay, so let's first go to my filters that I have over here. I can go with my hole diameters, and I can use this filter here. Now, what I'm going to do is as follows. As far as from goes, I'm going to leave it at 0. In other words, I want it to go from the very smallest possible diameter up until, now I'm highlighting this area. I'm just going to click on that, on this circle over here. That's the largest that I want to use, a 20 millimeter diameter. Okay, all I have to do now is find the holes. Click on find holes, and you'll see all of the holes were found, and we can see them now on the part. Every single hole was broken up into different shapes. We can see all the different shapes for the holes. Okay, we have different shapes, different groups. Every single shape is broken up into different groups. You can see if I right click over here, if I right click, you can see the show hole, and you can see the shape of that particular hole. Okay, if I go into groups, you can see also the group as well. The shape of the hole of the group. You can see the diameter values of the group as far as the upper levels. All the information is captured with the features of the holes. So I'm just going to accept what I have over here. I'm going to choose my spot drill. And now let's go to our levels. Now, the drill recognition recognizes the depth of every single hole. But in this particular case, with the spot drill, I don't want it to go to the depth of every hole. I just want the diameter of the spot drill to go to match up to the diameter of the top of every single hole over there. So for that, we give you the option of depth edit. In depth edit, all I need to do are two things. The first thing is click on Auto Chamfer for Spot Drill and apply that to all. In other words, I want the spot drill to go down to the diameter of each hole in each one of those groups. Okay, that's why I clicked on all, not just the first group. In addition, the depth that I'd like to go down in each group is to the top of that hole. In other words, to the 0 level. So I'm going to just go right in here, 0, and apply that to all of them as well. We'll accept that. And all I'm going to do now is save and calculate. There we go. Take a look at my simulation. And let's take a look at Solid Verify. This time I'm going to make my Solid Verify slightly transparent so we can see through the part. Run my simulation. You can see that every single hole has a spot on it according to the diameter of that hole. And if I show you from the side view, you can see also that each one goes down to the proper depth that it needs for that particular hole, for the spot. Okay? Showing that over here, you can see that as well. Now, next, I like to do now one hole itself. So I'm going to do now drill recognition, and I'd like to choose this particular hole over here. The reason why I'm doing that, because I happen to know that this hole is a 6.8 millimeter hole, which I have over here, as well on this level over here. So I'm just going to choose that hole. The way I choose only that diameter is when I go to hole diameter, I'll click on from, click on that edge over there, and you'll see it'll automatically fill up both edges. In other words, only that diameter will be chosen. Find holes, and you can see those groups have been chosen. We'll accept that. Choose the drill that I need. And as I said, this is a 6.8 millimeter drill. And now in this particular case, I do not need to touch the levels. The reason for that is because the levels, like I said, are automatically recognized. The depth of each hole is recognized. So I don't have to go in there. All I need to do is if I want to choose my technology, whether it be G81 or PEC G83, and whatever technology I may want to use, let's say only going down every 3 millimeters, save and calculate. And we'll run our simulation using Solid Verify. And you can see, I'll put it on the front view. You can see that's going down to its proper depth. This one is going down to over here. This one is going down only up until this point over here. In other words, it's recognized the feature of every single hole to their proper depth. This can also be seen very clearly over here as far as those holes go. Okay, next. I'm going to load another part. Now this part is a little bit of a heavy part, so it may take a few moments to load. But this is what we call automatic hole recognition and machining. Now, what does that actually do? It recognizes holes, and as you can see, this part has many holes, and classifies them into different shapes and groups, then converts the holes into different machinable segments, then puts the proper machinable segments to feature sets, and then chooses the proper technology from the technology database, and then generates the operations. It sounds like a mouthful, but it does exactly all of that. Let's see how this works. Okay, now when I go to operations, I'm just going to go to, here we go, operations, add. Okay, just a moment. Okay. We reload that part. And we'll get this working again. Okay. Okay, going to add recognition, hole recognition and technology from my part database. Now, this will take a few moments to load because, like I said, this is a relatively heavy part. And what it's doing right now, it's actually parsing the part and checking for all the holes. Now, you'll also note that this particular part has holes not only from the top, but it has from all sides, different angles. And as you can see again, every single shape has been recognized, broken down into different groups for different sizes. You can see all the different shapes over here. All I have to do now is continue on down to put them into different features. For example, this shape is a drill and a chamfer to it. Okay, this shape is a drill, chamfer, and a thread. So every single thing is picked up as we go along. Next, we recognize the machinable features. We also now attach them to different technologies, for instance, peck drilling, chamfer, profile milling, and tapping for this particular group. And then we go and generate the operations. Now, this actually, because this is a large part, this will take, like I said, approximately 1 minute. But what it's doing right now, it's actually taking all of the holes and applying all of the operations to the holes. I'm sure there'll be over 100 operations created by this. So like I said, this will take just a moment. And but the end result, well, you'll see that in a moment, is that you'll have an operation for every single one of those holes. So let's give it a moment so that it can complete the process. Okay, by the way, I have someone else here on the line with me. Steve, is my voice coming out okay? Because someone said they can't hear me that well. Steve, can you hear me?
Well, after you took me off mute, Sid, I could. I was talking.
Okay, I'm sorry. Okay,
no, I'm hearing you. You're coming through loud and clear, Sid, and I did ask you a question. I mean, how long would this part take to program manually?
Oh, manually. Oh, I don't even want to start thinking about it. As even the most um, experienced user, I'm sure would take them a good hour, even if you knew every single hole, just to start programming. And I'm being conservative about that. It could take even longer. So this in itself, like I said, it may seem like it takes a few moments over here, but the end result is it actually goes much quicker than programming it all by yourself.
Well, and then the accuracy too, Sid, correct?
Yeah, exactly. And
Yeah.
like I mentioned, this is on, I'm using this now on a 5-axis machine. And well, we'll see the results in just a moment as this goes along. Okay, we're getting some action over here. Now, you'll also note that the home positions are automatically being created for all the holes and for all the machining that's needed. In other words, all I did was create one hole position on this part. The automatic hole recognition machining creates automatically all the home positions that this particular machine can handle. And as you can see, we even have a preview of what's going to be done on the part itself. Okay, you can see all the tool paths over here. When I exit, you can see all of the operations on the part itself. And to show you this quickly, we have approximately 129 different operations that were created over here. Running my simulation quickly from the very top, solid verify. You can see every single hole is being machined and recognized. Let me just stop over there because you get the gist of what just happened over here. Okay, let me now continue to my next part. Okay, Hole Wizard process. Now, in SolidWorks, we have something called Hole Wizard. In other words, you can build holes exactly according to specifications in SolidWorks. Now, by doing that, we can say to ourselves, you know what? If we get all that information from SolidWorks of exactly what the hole size is, what type of hole is, why not recognize that in features and create the operations for that? And these operations are just using what we call a machining process design specifically for Hole Wizard process. So let's see how this works. These holes here, every single one of them was created using the Hole Wizard of SolidWorks. So if I go to Hole Wizard process over here, you can see we have a list of 4 different types of holes that we support. For example, tapped holes. If I take a look in the part, I have some tapped holes here. If I were to click on tapped holes, the dialog will pop up on the right-hand side, and all I have to do is click on the hole itself. By doing so, it'll recognize every single hole that was made with that particular pattern, okay, in the wizard. It'll recognize what type of hole it is, as we did with the tab. All I have to do now is just accept it. And what we have now is 3 operations being created for those holes over there. If I want to do a counterbore hole, same thing. Click on one of the counterbore holes. You can see all of the counterbore holes that was created with that particular wizard are recognized. All I have to do is accept it. And again, we will have the operations needed. In this particular case, I'm going to have 5 different operations for the counterbore holes. But wait a minute, you know what? Let me stop what I was doing over here. I'm going to right click over here and just actually going to, I'm going to delete these operations that I have over here. And what I'm going to do Remember I said drag and drop of templates? Well, what we've also done is hole wizard process. We turned our hole wizard process into drag and drop as well. So if I want to count the bore hole, I'll just grab the count the bore hole, drag the process to the hole. Without even going into the hole wizard process, it'll create the operations for that set of counter bore holes that was created in the wizard. And you'll see this in a moment. The same thing with any other of the operations over here. The tapped holes, I'll choose a tapped hole over here, click, drag it to that one over here. And the same thing will happen. It will recognize those tapped holes. I'll just run my simulation just for a moment so that you can see exactly what happened over here. We'll go over here, run my simulation, solid verify. And you can see that using the hole wizard, whenever you have a part using hole wizard, this works beautifully. Okay, next. Now I'd like to get to what I like to call many times is the ultimate in feature recognition. It's the Imachining 3D, and that is truly the ultimate in feature recognition. It'll recognize the entire part and create the operations for the part. And in this particular case, I on purpose took a part that's prismatic. Okay, so as you see, I have here a prismatic part with many different types of pockets, small pockets as well, those small little ledges over here. This is a pretty complex part. I'm trying to program it. If I were to go into Imachining 3D, okay, all I have to do, I don't have to choose my target. It's already we already know what it is. So my geometry is automatically recognized. All I have to do is add the tools. And in Imachining 3D, we can add multiple tools. So for example, I can select my first tool, because over here in this particular part, I need several tools. I'm going to start with a 6mm end mill. Then I'm going to continue down to my next tool, which will be a 3mm end mill. And I know I have some smaller pockets. So for that, I'm going to use even the next tool of a 2mm end mill. And actually, I can go down as far as I need. I can put in as many tools as I need. Now, each tool can be defined, have its own technology defined to it. Okay? I'm just going to have each one of them with a wall offset of 0.2 millimeters. Okay? T1, T2, as well as the 2mm end mill, the T3. Okay? What I'm going to do now is save and calculate. And what you'll see now is really cool. One operation, 3 operations being created. You can see it all being now calculated. Tool paths being built. And as we get now to the third operation, you'll see even the tool paths going into these small areas over here. To show that actually a little better, I'll run my simulation as soon as this finishes calculating. Run my simulation as I said, solid verify, and we have our first end mill, the 6mm end mill, doing as much as it possibly can. Now my second end mill, the 3mm end mill, continuing where the 6mm end mill left off. And as you can see, it's going into these areas where the other end mill, the 6mm end mill could not go into. And when this finishes, which will be in just a moment, you'll see now that the 2mm end mill is going into the areas where the 3mm end mill could not machine, and only machining in those areas. So this is a perfect combination, just one operation, recognizing all of the features in Imachining 3D and machining this all the way down to here. Now, remember I showed you before drag and drop? What if I did this for drag and drop for Imachining 3D? Let me delete all of my operations here. And again, if I go to my process template, I have one over here, the 3 operations. Just take that, drag it, and put it to the part. And again, I'll get the exact same results. Now, as far as the process templates, I can make as many process templates with all different kinds of combinations that I want. So the tool of templates is something that's it's automation, but it's automation created by you, by the machinist, by the programmer, whoever works on the program. That's who creates the templates. Okay, and again, as you can see, everything is being calculated, and we're getting a tool pass just by simply dropping the process template on the part. Again, we'll run our simulation, and you'll see we'll get the exact same results. Okay, now after this, I have one more part to show. Okay, and as you see, again, we're getting the exact same results that we had before. Okay, so let me now load my very last part. Okay, now we all know about Imachining 2D. I mean, it's been around, one of our most successful, one of our best and most I'm always awed every single time I see this. But we've now added feature recognition capabilities to our Imachining 2D as well. What do I mean by that? Let's take a look at just this part itself. If you take a look at the outside of this part, we'll start just with the outside, and then we'll take a look at the pockets. If we take a look at the outside of the part, if you wanted before to create an operation that works from the outside stock, okay, to the boundary of this part, to the outside feature of this part, to create that chain geometry, it was almost a nightmare. I wouldn't say almost a nightmare. It was a nightmare. You'd have to pick all these edges. They're all on different levels. It was really, wasn't the easiest thing to do. What we've done now is very simple. If I were to go into Imachining 2D, we have here several new options of feature recognition. Our first one, the one I just talked about, is this one over here called outside. Here we go, outside feature recognition, where it automatically recognizes the outside feature of the part. And I note I don't even pick a geometry. All I need to do is choose a tool. In this particular, I'm just going to use one tool for now. Okay. And when I choose a tool, what does it show you? It shows you, it goes to give you a little preview of what's going to be machined. So you see that it recognizes the outside of the stock and up until the outside feature of the part itself. Levels, you don't even have to deal with levels. All I have to do now is save and calculate. It'll now apply the toolpath to the part itself, as you can see over here. running a quick simulation, you can see that the outside was easily machined in just a few moments. Now, I'm going to do another operation here. And this time I want to work on the pockets. Okay? So again, I'll go to Imachining 2D. And in our first option here, we have what we call feature recognition by faces. All I have to do now is just click on the faces I want to machine. I want to click on that one, that one, that one, and you can see itself being added over here. That, okay, that one over here. All of these faces I can pick, and note also that these faces are not necessarily on the same level, okay? Again, all I'm going to do now is just choose my end mill. In this particular case, I'm going to choose, you know what, just the same end mill I had last time. I'm going to choose the 14mm end mill. And again, you'll see that we automatically recognize what is going to be removed. And you can even see the levels are also automatically recognized as well. Save and calculate. And there you have it. Your toolpath is being created, and you can see it on the part itself. Again, running the simulation. You can see every single level is machined out and exactly according to its level. Now, what would happen if I were to take this first operation and suppress it as if it does not exist? Well, in my operation that I have here, which is now the only operation I have, let me just go back into it. Look what happens. It automatically recognizes what stock has to be taken off. The stock was not removed yet, so it automatically updates itself. This is true recognition, feature recognition of the part. All I have to do is calculate. And this time we have a toolpath that's different than we had before, because now we have to machine the outside as well, because we have not machined that yet. Again, solid verify. And you can see now a different toolpath, but on each level. Okay? Now, just to throw in one more little option over here. With Imachining 2D, what if I had the outside as a template? Okay? I have one over here as a template. I'm just going to take this, drag it to the top of the part, or to the part itself. And there's your toolpath. No need to do it. So in other words, you're taking your template, something that you created, applying the feature recognition of the Imachining, and you have your operation in just a matter of seconds. So the bottom line is, as Steve mentioned before, SolidCAM's feature recognition is a tool that gives the machinist, the user, the programmer, the power to decide exactly how he wants to define his technology to the part with ease, by automatically recognizing the features and applying his technology or her technology to the part itself. Okay, this makes SolidCAM the choice program for the machinist. Okay, I see we have a couple of questions over here, and I'll try to go through them. By the way, as I mentioned before, this has been recorded, and this will be available later on our website. Okay, when selecting the option to use the filter, he chose 12.5. I'm assuming that the filter to work includes the 12.5 diameter and smaller to exclude. That is correct, exactly it. Now, in this particular case, and I'm going to show you the part, the reason why I didn't actually choose that hole is because that actually edge was a chamfer. So there was no pocket in there. In other words, the hole itself, the actual hole was smaller. That's why it was not chosen. Okay. Okay. That's it for now. First of all, thank you everyone for joining the webinar. And that's it. And we'll see you in our next webinar. Take care. Have a great rest of your week. And until our next time. Bye-bye.
Thanks, Sydney.
You're welcome.